Hey everyone. So in my Kubernetes installation series video, you will find out the RK1 installation, Rancher Kubernetes 1, Rancher Kubernetes 2, and uh, I've recorded one video wherein you can find out how we can set up kind cluster also for a beginner with a very less resource. That's a lightweight Kubernetes cluster. Now I'm going to talk about in this video. You may find out many videos in YouTube around kubeadm installation. kubeadm is our vanilla Kubernetes flavor, right? This is the same method you can find out in kubernetes.io website. That's the vanilla Kubernetes. I'm going to install the kubeadm, but I'll be installing on CRIO. So not with the containerd, not with the Docker, because kubeadm supports many CRIOs, many CRI. That's container runtime interface only it requires. So I'll be using CRIO, right? So how we can set it up, that's a new video. I'm going to discuss about all the steps. The steps you can find out here in this link also, because the link, if you have available, you can find out and you can perform the practices. Excuse me. Okay, so the first thing first, what we need. I need at least two virtual machines, so that first machine can act like a master, another one I need as a worker. So now here, if you see, I have logged in into both the machines. So I have this server, this is going to act like a worker. So these two machines I have, I can take this screen as big, and I'll try to make the font more visible. Yeah, here in this way, and here also. Okay, cool. So first thing first, we need in both the machine is there are few steps which we need to execute on both the machines. So let's start executing. So we should be making sure that there is no swap space, because kubeadm doesn't accept the swap space. And before that, the minimum resource requirement for both the machines, right? Resource. So we need at least 2 CPU and 4 GB of RAM, right? In my case, I have 2 CPU and 4 GB of RAM. So you need also. So now this is making sure that swap. However, if I run free-h, you see that I don't have any swap space. But if you have, then you can run this command, right? So this will make sure that in your etcfs tab, if there is any swap line, it will mark this as comment, and any running swap also it will make as turned off, right? So with the swap off, so you can run these, and I'm running both the any commands on both the machines, right? So far, so this is one. Then you have two different CRI options normally here, which is mentioned in this document, but I'll be using the CRIO method. So container deinstallation, if you have Docker installed in Docker, you need to run this command in config.toml, so that the containerd should be not disabling the CRI. But I'll be using this method, right? So I'm going to execute the CRIO installation. So I'll be running apt update, then I'll be running apt install for these few softwares, and I have to run on both the machines. I'll be executing one by one in both the machines. So here, right, and let's see the apt update, and then the installation. When the installation will finish, I will export OS version and CRIO version, so that I can later use this as variable here. Okay, so I'll be copying and up to here, and I can simply go on the first machine. I'm running every command, just copy paste and run. You can also do copy paste and run. It's very easy, very simple. Here also I'm doing same, copy paste and run, right? So next command is I need to install CRIO, and CRIO runs it. So these set of commands, these 4 set of commands, I can simply run, execute one by one in both the machine. So here also I'm running, and here in the second machine also, the worker machine also I'll be running. So I'm installing the commands, installing the binaries, packages, you see here like this. And then what I need to do is, this is a new way, by the way, because if a few of you might not be aware of, then Kubernetes has moved out from for its official packages from the Google running repositories. Earlier it was yum.kubernetes.io, right, and apt.kubernetes.io for the distribution specific repositories which you could add in your Linux and you could download and install. But now it's like Kubernetes has migrated and everything to pkgs.kts.io. So the new, from now onwards, the date today onwards, if you want to install, then you have to change these things, right? So the way has been changed now. So now I'm adding the repository and I'm adding the key rings here, both the machines again. So this is client machine, added. This is master, added. Okay, good. Now I'll be installing the packages: kubelet, kubeadm, kubectl. Kubectl you need only on master, or otherwise if you're planning to run kubectl from your client machine somewhere else also, then you need kubectl not to install on all the machine, but kubelet and kubeadm is something which you really need. So I'll be installing no harm, so I'm installing these things in both the machines. So I'm running here in master first, then I'll be running in a worker machine also, right? The step-by-step execution, it's really easy and things will be working seamless. Okay, yeah, cool. So up to here we are good. Now there are a few parameters before we run kubeadm init. Before we initialize our Kubernetes cluster, we need to run few more things. We need some kernel parameter tuning. So you can simply copy paste. You don't really need to bother about anything else. I have just keep everything ready here. So these two parameters, then this one also copy it, put up here, then in second machine also. So far every step I've executed in all the machines, right? Yeah, this way, the kernel parameter tunings, we are good. Now we are here where we need to execute steps on master only, and it's specifically mentioned here. So if you see the first one, don't execute the first one, because then it will we are not supplying any CRI socket here specifically to kubeadm that hey kubeadm, this is the CRI we are going to use, right? You should consider this. So this command is talking about the CRI socket. So we are basically, with this command we are trying to say with kubeadm that hey kubeadm, please initialize my container with this pod network specification and with this CRI socket. Don't use the container D or something else if you already have, right? So I'll do is I'll copy and I have to execute everything on master only now. So I'm on master and I'm gonna simply execute this. So if you run, you see that kubeadm will start pulling the configuration images, the etcd, controller manager, core DNS, scheduler, API, all the orchestration components will start pulling up. And when the image pull is done, cluster will initialize and it will print the further instructions, like to make the kubeconfig file entry, to it will give us this token also so that we can join our worker node. The worker node, so far everything is okay. The binaries and commands we have already installed. So if you see, this is coming up, it's waiting for kubelet, and yeah, we're good. Our master node is good, it's done. And to start the cluster, I just need to execute this command. So here we go. This command is not required, right? And you see here that the token and the discovery token both is printed here. I can simply follow this one. So if I run kubectl, let's say get node, just to make sure that cluster is fine. Yeah, cluster is fine. Master node 27 seconds back it says come up, right? Now I need to put the everything for the worker node. So if you go down here, right, for the worker node, how we can join. So if you see that sudo kubectl, everything is fine, we just need to pass at the end the CRI. So what I'm gonna do is I'll simply copy this command from here to this token, right? And I'll go ahead here in my worker node and I'll use sudo because I'm as a not non-root user, and then I can simply append this CRI section. Specifically, I'll tell my worker node also while joining that please use this CRI. Yeah, done. So when I'm doing this, you see that my cluster has joined immediately within a second even. And if I run here kubectl get node, you see that my RK2 client, both the machines, 7 seconds back it has come up, right? So if I run kubectl get excuse me pod in all the namespaces, we see that everything is running here. But now I need to do some other steps because it's KubeAdm. We need to install some CNI components also, right? So here is the pod network plugin which we need to install. I have two examples, Flannel, ViewNet. I'll not use Flannel because the network policy option is not available. It's simple overlay network. So I'll be using Weave. So I'm doing a copy here and I'll go here in master only because kubectl I have enabled for master. The kube config is available in master. So you see that deployment for Weave daemon set is done. Now I'll see the kubectl get pod all the namespaces, and I see that ViewNet is initializing. If ViewNet is getting crash loop back off or some other state also while it is initializing, don't worry. See here, it went into error. It's fine. Let this be ready. Now you see that 2 by 2, it's ready. Everything is running fine here. And if I go down now for the after the pod network, this metal LB option, it's purely optional. If you want, you can execute. So if I want, I can execute metal LB also. Metal LB is a simple load balancer service like in cloud, right? If anyone, you don't have an option. Metal LB is very small. I think I don't need to explain in a very big way, but yeah, while doing Kubernetes lab and working with your own virtual machine, there are three different types of services: cluster, IP, node port, and load balancer. Sometimes we need to expose our services with a load balancer type, but if you don't have an API based load balancer integration available, you are not working with a virtual machine, not in cloud, it's very almost difficult job. So Metal LV is one of the solution which has come up with an option wherein your machine is in whichever network, few of the IPs you can reserve. So let me do that. So if I run, right, simply copy paste and Metal LB will be up. Now what next you need to do is you need to create an IP pool. So again, I'm gonna do same thing. I'll run this command with IP pool, guys. It's very easy. Instructions are already there. So you see here that I'm giving a range of this IP, right? But I'll use simple IPs here just to showcase. So in my pool, I'm taking 4 IPs only. So I'll take the IPs ranges from 75 to 80 only. So if I will expose any services type as load balancer, let's say those services will acquire, the load balancer will acquire an external IP from these given source, right? That's why this load balancer service is. So what I need to run is I can simply run kubectl apply -f and this file. I have applied the first pool and L2 advertisement also I have enabled. So this is applied, done. Now if you want to install, let's say, ingress, right, with a Helm chart first, so I can install Helm binary also. It's very easy, very quick and easy way. So you see here Helm installation is done. Cool. On my same machine, now you have two options. You can deploy your ingress as deployment and you can install your ingress as daemon set. What is the difference? So if you do installation with a deployment option, this ingress controller will try to acquire a load balancer IP. And in your case, if you are not working with a load balancer solution, fortunately we have Metal LB already installed. So we are good with either of the option. But if you don't have load balancer service available in your Kubernetes deployment, right, the environment ecosystem where you are deploying your Kubernetes, and you don't have the API integrations available, as I said earlier, then you should not select this deployment option. You should be selecting daemon set option. In daemon set option, what happens is that ingress controller deploys on every node, worker node, as a daemon set. So when you are running ingress service, you're creating any ingress and you need to create a DNS IP, you can put in your DNS all the nodes IPs, right? Each A record all the nodes. So if in case one node is going down also, your ingress application will not be impacted, right? So that's one thing we can do with the daemon set. Daemon set option. Deployment option requires an ingress. So if I do the deployment with a deployment option, I think it will give us a good insight on our metal LB option also. So if I run kubectl before that, kubectl get SVC for all the namespaces, you see that external IPs we have none, right? And let me see if everything is healthy, right? So everything looks healthy, cool. And then I'm gonna do Helm installation, right? I'll install ingress nginx in ingress namespace, and if the namespace doesn't exist, I told Helm to create it. So the installation is going to be happen, and when this installation is done, yeah, here the installation is success. Now if I see kubectl get svc, guys, for all the namespaces, you see here now my ingress nginx controller, nginx ingress controller, has got one external IP, and if I do a curl or open this IP in my browser, you see that this IP I can use now. This is a load balancer IP which I can use now in my DNS for all the ingress hosts here, right? You see here, that's an nginx which got exposed. So if I'm creating another applications also, let's say, and I'm trying to expose as a load balancer, I will get another IP address here, and then that will be acting. Like let's say if I'm creating kubectl create deployment name as test coming from image is equals to nginx alpine enter, my deployment is created. Now if I want to expose this, I can run kubectl expose my deployment and run on the port 80, and the target port, which is my container port, is running on 80. If this would have been different, I would have given as different. And then at the end I'm giving that type, my service type is, please set it as, sorry, load balancer, and then I'm hitting enter. Yeah, oh sorry, the deployment name I haven't given. So kubectl expose my deployment, the deployment name is test. If you see this as exposed, but if I'm going ahead here in kubectl get svc and say a, yeah, so you see that another load balancer IP has now got assigned to this container pod, and I'm running curl 192.168.1.75. I'm getting ingress. If I'm running 6, I'm getting my nginx deployment. Welcome to nginx page, right? That's how the metal LB works, and you see that kubeadm is working perfectly fine. Now if you want, you can deploy cert manager here, right? Same way like we deployed earlier videos. And if you want, you can deploy matrix server also. Why we need matrix server? If some of you, let's say, not knowing, if I want to run kubectl top node just to see that my nodes or my pods are utilizing how much of CPU and memory, the matrix API is not available. That's how it shows, right? If I want to run for pods also in all namespaces or the current namespaces, it says not available. So for that reason we have to deploy the matrix server as a pod, because when this pod gets deployed and it will come up as running, then if we run kubectl top node, it basically, this pod captures the statistics of the resource utilization like CPU and memory, and it prints when we run kubectl top commands. That API gets called. Yeah, so we will quickly check kubectl get pod. If my metric pod is up, but you see that it takes some time because it's initialized first itself, and then it start taking the matrix also to start collecting matrix. So now you see that this is coming up. Yeah, it's good now, one by one. So now if I run, what happens if I run top pod again? Then it says that now the API is getting called, and we all can see the utilizations. And in the same way, if I want to see both the nodes, how much utilization there, so you see that the CPU percentage, CPU cores, and the memory bytes and memory percentage. So this was it for the KubeAdm installation, guys. You can feel free to follow this Elasticsearch, the dynamic storage provisioning, and then the monitoring and Prometheus of Grafana, etc. That's also. So if I quickly talk about the provisioners, dynamic storage provisioner, that's a local provisioner. If you have one machine, you can simply apply here also, right? And then this is a patch for making storage class default. kubectl get sc, you see that one storage class I have now, but this is not default one. So if I run this patch and then run kubectl get sc, you see that this is a default one. So if somewhere you are not specifically define the storage class, then this storage class will automatically pick up the request. And then if you want to try out this storage class, whether this has got set up correctly or not, then you can deploy these two examples. That's example of PVC and pod. Pod will be created, and it will create one persistent volume claim. It will claim for a volume. So if I run kubectl get pod, guys, pods have been created in my current. You see volume test container is trying to create itself, and it's creating still. It's running now. So when we say it's running, and we want to see kubectl pod, we want to see PVC, and we want to see PV also. You see that the PVC here has got created, and the storage class is local. So dynamically things are getting assigned, right? So this is a full-fledged cluster so far, the components we have deployed. So this is how you can start setting up your vanilla Kubernetes with CRIO as CNI plugin, CRI plugin, with View as CNI, with ingress controller, with metal LB, with matrix server and everything. This is a full-fledged server where you can start deploying your other components also. That's it for today.